Hello students. Today we are going to study the topic light. From the moment we awake in the morning to the time we sleep, we observe many colorful, bright, beautiful things around us. But question is, how we can observe them? How we can see them? As such, you all know that there is no direct contact in between the things and our eyes we are looking at. But the light which is coming from the near or far by object makes us the things visible. So if we question that what is light, then we should always remember that the light is a form of energy. It is just a form of energy which is invisible itself, but makes the things visible for us. So, light is very important. It makes the things around us visible. Whenever the light ray is reflected from an object or produced by an object, reaches to our eye, then we can see the object. Now, let us see that how can we see the light? Actually, we cannot see the light. But question is, what is light? What is its behavior? And we want to observe that. We want to know which type of properties light has. Initially, from very ancient times, the Greek people always meet that the light is group of or stream of particles. We can say that the light is always considered to be rays or stream of very fine particles which moves with very great speed. We can say that these particles are very small and they move with a very high speed. That's why we cannot observe them. And this was the particle nature of light. Yes, this nature of light is said to be particle nature. According to this theory, that is particle theory of light behavior, was approved by the legendary physicist Isaac Newton. Due to his giant personality in physics, this concept of particle nature of light was always considered to be true. But if we move to the further details of particle nature, then we can see that different phenomena like interference, diffraction, polarization, etc. could not be explained by the particle nature of light, which was the major drawback of particle nature of light. As we know, when the light energy travels, if an obstacle is posed in between the path of the light ray, shadows. And why it is so? Because there is the blockage of the particles which are moving in the light. So that was always observed that light behaved like particle. But in the phenomena like interference, diffraction, polarization, the nature of light the nature of light as a particle was not shown. In 1600s, Christian Huygens proposed first time that light actually behaves like wave. Wave which has the particular characteristics, wavelength, frequency, some velocity, and has some changes in density of the medium in which they are moving, and crest or trough, which is formed by the vibration of the particle of medium. Christian Huygens said that the light is a wave and it actually moves like a wave. But due to the concept of corpuscular theory of Isaac Newton, it was already but due to the concept of corpuscular theory from Isaac Newton posed the difficulties in the wave theory of light. But in year 1807, Thomas Young, a physicist, backed up the theory given by Christian Huygens by his famous experiment on interference, the double slit experiment, in which he effectively shown that light behave like waves. See, what is the double slit experiment of Thomas Young? Thomas Young took the two slits. From these two slits, the light waves are allowed to fall. It was observed that the light spread like waves from a slit, and it can interfere with the wave or with the light coming from this second slit. And as we know that the light can only go through the clear paths. Beside this, Thomas Young observed another result, and it was that the light wave reached in the areas it should not be. That's why it was said that the light should behave like waves. And Thomas Young hence proved the wave theory of Huygens. But in the starting of 20th century, Albert Einstein, that is the greatest of the greatest, Albert Einstein explained the photoelectric effect in year 1905. In photoelectric effect, we observed that whenever an ultraviolet ray falls on a metal surface, Then due to the high energy of ultraviolet ray, the electron come out of the metal surface. That's why Albert Einstein explained this phenomenon of photoelectric effect by saying that light is a ray, it is a ray made up of small particles or energy packets which are known as photons. These energy packets, which were called photons, can be considered like particles, and that's why the particle theory again stepped back into the dual nature of light behavior. When we had reflection, refraction, and scattering process, we said that light ray behaves like a particle, but for interference, diffraction, and simultaneous similar process, we found that only particle nature cannot explain these phenomena. That's why we put the wave theory and we found it quite correct, explained, and we found that the wave theory correctly explained the interference and diffraction. It simultaneously explained the reflection, refraction, and scattering. So we said that wave theory is actually the correct theory which explains the behavior of light. But when the photoelectric effect was observed, it was found that only wave theory could not explain this effect. And due to Einstein's explanation of photoelectric effect, the particle nature again came in. In this, the photon, which is consisted in the light ray, the energy of photon is given by the formula E is equals to h nu. Here E is the energy of photon, h is the Planck's constant. The Planck's constant has the value h is equals to 6.6 into 10 raised to power minus 34 joules second, and nu is the frequency of the light wave.